Now new result, vector equation of a line passing through a given point and a given parallel vector See, to understand this result in space, now everything we are discussing about a space, vector equation of a line in space. So this is x-axis, this is y-axis, and this is z-axis. Now in this space, this is a line. On this line, suppose this point is given. Let me say point is A. A is given point. Line is passing from this given point, and it is parallel to a vector. Suppose this line is parallel to a vector B. Line L is parallel to a vector B and it is passing from A. Now how to find its vector equation? So if position vector of this point A, position vector of this point A is vector A, and if P is any variable point, this is any point, it is not fixed, variable point. P can be at this location, it can be here, it can be here, anywhere. So P is a moving point or variable point. This is fixed, it is given point whose position vector is vector A. This is given vector parallel to that line, and P is variable point. Suppose that position vector of this point is vector R. Suppose this vector is vector R. Then its equation, vector equation is, I am putting here vector equation in detail. Vector equation of a line passing through point, a given point A, passing through given point whose position vector is vector A. Position vector of this point is vector A, passing through given point, having its position vector vector A and parallel to vector B. So vector equation of a line passing through given point, having its position vector vector A and parallel to vector B is vector R is equal to vector A plus lambda times vector B, where lambda belongs to R. Lambda is any real number, and here vector R is the position vector of, it is position vector of any point, or we say variable point, of line. So this is vector equation. Now, to obtain its Cartesian form of this equation, if variable point, if a vector r is position vector of variable point, suppose vector r is x times I cap plus y times j cap plus z times k. Given point is a, whose position vector is vector a. So vector a is given, that is, suppose it is x1i plus y1j plus z1k, and vector b, which is a parallel to this given line. Vector b is, suppose ai plus bj plus ck, then Cartesian equation of line is, it is x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. This is said to be Cartesian equation or Cartesian form of line. If a point on line is given and a vector parallel to that line is given, so using this formula we can find Cartesian form. As for example, suppose I take one question. Question is, find vector equation, Cartesian equation, vector and Cartesian equation of a line passing through a point whose position vector is 2i minus 3j plus 4k, and parallel to line is a parallel to a vector, suppose I plus 5j minus k. So find vector and Cartesian equation of a line passing through a point whose position vector is this vector and line is parallel to this vector. So we apply this formula. Say line is passing through a point whose position vector is this vector. So this is vector A. A point is given whose position vector is vector A. So here vector A is I plus 5j 2i minus 3j plus 4k. Line is a parallel to vector B. Vector B is I plus 5j minus k. So vector equation is therefore vector equation of line. Vector equation is vector R is equal to vector A plus lambda times vector B, lambda belongs to R. That means vector r is equal to vector a 2i minus 3j plus 4k plus lambda times I plus 5j minus k, lambda belongs to r. So this is said to be a vector equation of this line. And to obtain Cartesian form, now for Cartesian form, in Cartesian form, given position vector of given point, say scalar components we are taking x1, y1, z1. So here x1, y1, z1 is clear. So x1 is 2, y1 is minus 3, z1 is 4. So it is x1, y1, z1. Then given parallel vector, it's a scalar component, we take ABC. So here ABC are A is 1, B is 5, C is minus 1. So putting this formula, Cartesian form is, Cartesian equation is, formula is x minus x1 upon A, y minus y1 upon b, z minus z1 upon c. That is x minus x1 is 2 upon 1, y minus y1 is minus 3. So putting here minus 3, minus minus plus 3 upon b is 5, z minus z1, z1 is 4 and c is minus 1. So if you observe this equation, means if you observe this formula, then method is, here in numerator keep x, y, z. These are scalar components of a variable point x, y, z. Then put minus, minus, minus. Then x1, y1, z1, that is a scalar components of given point 2, minus 3, 4. So put here 2, minus 3, 4. So because y1 is minus 3, minus minus plus 3. And in denominator keep scalar components of parallel vector 1, 5, minus 1. So this is the method, short way to get Cartesian equation. Now say in this equations, this is vector equation, this is Cartesian equation. If a point is given whose position vectors are given and a parallel vector is given, now I am explaining meaning of this lambda. What is role of lambda? So see, to understand the role of lambda, here this is x-axis, this is y-axis and this is z-axis. Whatever I explained in theory, in formula, I am explaining same thing in diagram. For this example, suppose this is a line. Now this is position vector of a given point. So if here given point is A, whose position vector of given point, suppose this is vector A, that is 2i minus 3j plus 4k. This is vector B. B is already given 1i plus 5j minus k, and variable point is P, which position vector is R. So A is, vector A is 2i minus 3j plus 4k. So this vector is, here it is 2i minus 3j plus 4k. It is this vector. This is variable point whose position vector is vector R. And vector B is I plus 5j minus k. So this vector is I plus 5j minus k. Now vector R, it is 2i minus 3j plus 4k plus lambda times I plus 5j minus k. Now I am explaining what is the role of lambda. Here lambda is any real number. So say simplifying this, vector R is 2i minus 3j plus 4k. Here lambda times I, so it is 2 plus lambda times I, 2 plus lambda times I, minus 3 plus 5 lambda times j, 5 lambda minus 3 times j, minus lambda plus 4, that is 4 minus lambda times k. Lambda belongs to R. So this equation can also be written as this form. Vector R is a position vector of variable point whose scalar components are now visible in lambda form. Now here if I keep lambda equal to, suppose if we take 0, then lambda equal to 0 gives vector R equal to, put here 0. So what you get, 2i plus minus 3j plus 4k. Lambda equal to 0 gives position vector of given point. This is position vector of a given point. Now I change lambda. Now I am taking lambda 1. Taking lambda 1, if you put here lambda 1, 2 plus 1, 3i. Put here 1, 5 minus 3, 2j. Put 1, 4 minus 1, 3k. So this is position vector of a point which is distinct from the point whose position vector is given. So this is position vector of any point which lies on this line. So this may be position vector of this point. So this vector may be position vector of this point, that means it may be this vector. Let I say vector R1. Suppose if I take lambda equal to 2, putting lambda equal to 2, put here 2. So vector R is, putting here 2. So 2 plus 2, 4. 4i. 10 minus 3, 7j. 4 minus 2, 2k. So again a new vector. So it will be position vector of a new point which lies on this line. So this can be position vector of this point. So this can be vector R2. If you take R lambda equal to, suppose minus 3, put here minus 3. So 2 minus 3. So that is minus I. Minus 15 minus 3, minus 18j. Put here minus 3. So 7k. So again we are getting a new vector. So changing value of lambda, every time we are getting a new vector. But whatever it will be a vector, whenever you derive vector R from this equation by changing value of lambda, every time you will get position vectors of points which lie only on this line. So this can be position vector of a point, it may be somewhere here. This can be vector R3. Again, if you could change here value of lambda, lambda can be taken any number, any real. You can take lambda root 2, you can take lambda 10,000, you can take lambda minus 11 by 13. As you change lambda, we get changing lambda, every lambda gives a new point. every value of lambda, corresponding to every value of lambda, we are getting a new point on this line. New lambda, that is new point, that means position vector of new point. These are position vectors of points on this lambda, on this line. So this is a equation which gives position vectors of all the points on this line. Hence this is said to be vector equation. It gives position vectors of every point which lie only on this line. So this is the meaning of vector form. And see, here vector R, that is, now I am explaining a Cartesian form. See here, vector R is xi, yj, zk. It was vector, position vector of vector R that we have taken in this discussion. Now if you compare components on both the sides, then x is 2 plus lambda, y is 5 lambda minus 3, z is 4 minus lambda. So that means x minus 2 is lambda, y plus 3 by 5 is lambda, z minus 4 by minus 1 is lambda. That means now comparing this lambda, you can see that x minus 2 by 1 equal to y plus 3 by 5 equal to z minus 4 by minus 1, which is Cartesian equation. Find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3i plus 2j minus 2k. So here we can understand this question by diagram. This is x-axis, this is y-axis, and this is z-axis. Suppose that this is a line whose equation is required. It is passing from a point. Let me take this point is 1, 2, 3. This is 1, 2, 3. This is origin. This point is A, whose coordinates are 1, 2, 3. So what will be position vector of this point? So position vector of this point we denote by vector A. So here vector A will be, because this vector terminal point is 1, 2, 3, initial point is 0, 0, 0, position vector of this point will be 1i plus 2j plus 3 times k. This is a parallel to, let me take parallel vector is B. It is parallel to 3i plus 2j minus 2k. Line is parallel to this vector. So vector equation is vector R is equal to vector A plus lambda times vector B. Lambda is any real. Changing value of lambda, every distinct lambda corresponds to distinct point which lies on that line. So R, vector R is position vector of variable point. Any point whose position vector is vector R, this P is any point. So vector R is vector A I plus 2j plus 3 times k plus lambda times vector b. Vector b is 3i plus 2j minus 2k. Lambda belongs to R. So this is vector equation. And Cartesian equation is, say formula is x minus x1 upon a equal to y minus y1 upon b equal to z minus z1 upon c. Cartesian equation, say formula is x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. See, a, b, c are scalar components of parallel vector. These are a, b, c. So put in denominator a, b, c, scalar components of parallel vector. And here we are putting x1, y1, z1, that is scalar components of given point. x1 is 1, so put here 1. y1 is 2, so put here 2. z1 is 3, so put here 3. If this is minus 3, so minus minus it will be plus 3. So this is Cartesian equation. Now next result. Equation of line passing through two distinct points. Equation of line passing through two distinct points. Say this line is x-axis, this line is y-axis, this line is z-axis. Suppose that this line is passing from 2 points. A is x1, y1, z1, B is whose coordinates are x2, y2, z2. We want equation of this line. Now see, this is origin. So this vector is position vector of point A. Let me say this vector is vector A. This vector is position vector of point B. Let me say it is vector B. So say if a line passes through two distinct points, A x1 y1 z1 and second point is B whose coordinates are x2 y2 z2. Line passes through two distinct points A x1 y1 z1 and B x2 y2 z2 such that position vectors of point A and B are vector A and vector B respectively. Then vector equation of this line is, say vector R equal to vector A, vector R is equal to vector A plus lambda times vector B minus vector A. Lambda belongs to R. Say in previous result we discussed that if a point is given and a parallel vector, vector B is given, one point is given and parallel vector is given, then result was R bar is equal to vector r is equal to vector a plus lambda times vector b. But here, see, vector b, it is position vector of this point. This is vector b, it is not parallel to this vector. So what will be parallel to this line? So parallel to this line, it can be taken a vector AB. See here, if you imagine this vector AB, say vector AB, you can imagine this vector AB. This is vector AB. If you show direction towards this side, this vector is vector AB, so this is vector AB. So what will be vector AB? Position vector of B minus position vector of A. Position vector of B, terminal point minus initial point. So vector B minus vector A. So this vector is vector B minus vector A. So this can be taken as a vector parallel to this line. So in last theory, vector B is replaced by vector B minus vector A. So don't be confused in symbol. Vector B here we have taken as position vector of B, point B, and in last result vector B was a parallel vector, but now parallel vector is vector B minus vector A. That means this vector, this is parallel, this is parallel vector, and it will be vector B minus vector A. So this can be taken a parallel vector to a given line. So this is vector equation of line if 2 points are given. Now to obtain its Cartesian form, if vector A is, now see, vector A will be x1 times I, y1 times j, z1 times k, and vector B will be x2 times I, y2 times j, z2 times k. P is any point whose position vector is vector r. If this is vector r, P is any point whose, if coordinates are x, y, z, variable point, then vector r can be taken as vector r is xi plus yj plus zk. Then Cartesian equation is say in last theory numerator was x minus x1, y minus y1, z minus z1. This was numerator, terms in numerator. Denominator, we had scalar components of vector parallel to line. It was small a, small b, small c. Now these numbers will be replaced by x1, x2 minus x1, y2 minus y1, z2 minus z1. Vector b minus vector a. Vector b minus vector a. x2 minus x1, y2 minus y1, z2 minus z1. So this is Cartesian form. Now to understand this question, we take, to understand this result, I am taking question. Question is, obtain vector and Cartesian equation of a line passing through two distinct points 2, -1, 3 and 4, 2, -2. We want equation of line passing through two distinct points. So say, applying this theory, this is x1, y1, z1. This is x2, y2, z2. So here, vector A, it is 2i minus 1j plus 3k. This is vector A, that means from these components. Vector B is x2i, y2j, z2k. x2, y2, z2 from these numbers, vector b. So that is 4i. This is position of vector of second point. These are coordinates of point. From coordinates we can write position vector of that point. So take coordinates as a scalar components, join them with I, j, k. So vector A, vector B, we have this result. Now we find vector B minus vector A. Vector B minus vector A is 4 minus 2, that is 2i. 2 minus minus 1, that is 3j. Minus 2 minus 3, that is minus 5k. So vector equation is, using this result, vector R is vector A plus lambda times vector B minus vector A, lambda belongs to R. So that means vector R is vector A, that is 2i minus j plus 3k, vector A plus lambda times, this is vector parallel to that line. So 2i plus 3j minus 5k, lambda belongs to R. This is vector equation. And Cartesian equation is, see, formula is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So from this formula, x, y, z. Now see, minus x1. What is x1? x1 is 2. So minus 2. You can see here or you can see here x1. y1 is minus 1. So minus minus plus 1. Minus z1. z1 is 3. You can see here, you can also see here. Same. 3. Upon x2 minus x1. 4 minus 2. Or x2 minus x1. y2 minus y1. 2 plus 1. z2 minus z1. Minus 2 minus 3. That is x minus 2 upon 2 equal to y plus 1 upon 3 equal to z minus 3 upon minus 5. So this is Cartesian equation. And this form you can also write from this equation. Say, look here, vector R, that means scalar components are x, y, z. So put here x, y, z. Then look, 2 minus 1, 3. So these numbers are subtract in numerator, minus 2. Then minus 1, that is plus 1. Minus 3. In the denominator, keep this scalar components. 2, 3, minus 5, keep in denominator. So this is Cartesian equation. So from vector equation directly you can write Cartesian equation. From Cartesian equation you can also write from vector equation. If any question you are given Cartesian equation and to convert into vector equation. So first of all, remember Cartesian equation should be in this form. X, coefficient of x must be 1, coefficient of y must be 1, coefficient of z must be 1. Then here minus x1 minus y1 minus z1 upon ABC. Let me take question to understand that procedure. Now see, question is convert this equation into a vector form. Here this equation is not in vector form, it is in Cartesian form. But to convert Cartesian form into vector form, say here we have to change its form. Coefficient of x is 2, it is not 1. So first of all, what we shall do, this should be converted in this form: x minus x1 upon a, y minus y1 upon b, z minus z1 upon c. If Cartesian form is in this form, then these numbers are giving a direction ratios. That means scalar components of parallel vector. And here these three numbers are giving position vector of particular point. So equation must be in this form. Then if it is in this form, then we can say vector r equal to x1i plus y1j plus z1k plus lambda times ai bj ck. So then this will be vector form. So to convert into vector form, we must have this form. Now say here 2x minus 1 by 4 equal to y minus 3 by minus 1 equal to 4 minus z by 5. See, coefficient of x, y, z. Coefficient of x, y, z must be 1, 1, 1. Means nothing should be with x, y and z. Here 2 is with x, so we should remove it. So what we do, here numerator and denominator divide by 2. So dividing numerator by 2, it is x minus 1 by 2, divide this by 2. Suppose I change here number 7, converting this into a little difficult form. So 7, so this will be 7 by 2. So numerator and denominator divided by 2. Then here y, coefficient of y is 1. Already here is 1. So keep this as it is, no change. Here coefficient of z is minus 1. We don't want minus 1. We want coefficient of z 1. So to change minus z into 1z, here multiply and divide by minus 1. So z minus 4 upon minus 5. So see here x, 1x, 1y and 1z. This form is obtained. And see 7 by 2 minus 3 minus 5 are direction ratios. Now to convert these three numbers showing direction ratios in better form, what we do? Here now no change in numerator. Numerator keep as it is. Because we don't like these fractionals. So to convert this into integral form, what we do? Multiply denominator by 2. So multiplying denominator by 2, this will be 7 minus 6 minus 10. So value remains unchanged. See, this triplet is showing direction direction ratios. Then multiplying this triplet by 2, we are getting new triplet. It also shows direction ratio. So there are infinite many set of direction ratios. Any triplet showing direction ratio, you multiply by any number, you will get a new set of direction ratio. So these numbers can be taken as scalar component of a vector parallel to that line. Now it is in this form. So say here line is passing from 1 by 2, 3, 4. This line is passing from point A, whose x coordinate is 1 by 2, y coordinate is 3, z coordinate is 4. And it is a parallel to a vector. Let me say if this is B, it is parallel to 7i minus 6j minus 10k. If here this somewhere here there is origin, then this vector is vector A, It is 1 by 2i plus 3j plus 4k. So vector form is, therefore vector equation is vector r is equal to vector a. What is a now? 1 by 2i plus 3j plus 4k plus lambda times b. B is 7i minus 6j minus 10k. Lambda belongs to R. In short, after getting this form, these numbers keep in this first bracket with ijk, and these numbers keep with ijk in second bracket, which is connected with lambda. So this is vector equation of that line, or equation in vector form. Now in this question, find Cartesian equation of a line which passes through the point -2, 4, -5. Line is passing from this point. Line is passing from this point. That means to understand this given information, I am taking here line. It is passing from -2, -4, -5. So here position vector of point A, it will be -2i minus 4j minus 5k. Somewhere here, if there is origin, then this will be position vector of vector A. Now this line is parallel to this line. It is parallel to, this is given line. This is required. Now this is parallel to given line. Now check equation. Say here x, y, z. X, y, z, coefficients of x, y, z are 1. If coefficients of x, y, z in numerator is 1, 1, 1, then triplet which you see in the denominator gives direction ratios of this line. So direction ratios of given line are 3, 5 and 6. That means given line is parallel to, therefore given line is parallel to vector 3i plus 5j plus 6k. So given line is parallel to vector B, which is 3i plus 5j plus 6k. From equation we can see parallel vector to given line. It can be seen from these numbers, but keep remember, before you take these numbers, check always coefficients of x, y, z. If coefficients of x, y, z are not 1, if they are like this, then whatever you see numbers in denominator, don't take direction ratio. Before taking direction ratio, you have to convert that equation in this form: x minus x1, y minus y1, z minus z1. So here already coefficients of x, y, z are 1, 1, 1. That's why 3, 5, 6 are direction ratios. Hence line which is a parallel to this line, vector parallel to this line is vector B. Now required line is passing through this point and it is parallel to given line. Required line is parallel to given line and given line is parallel to vector B. So required line will also be parallel to vector B. So because required line is parallel to given line, therefore required line is also parallel to vector B. This is a vector parallel to required line. So a point is given and we are having a vector parallel to required line. So equation of required line. Therefore vector equation, we are asked a Cartesian equation. So Cartesian equation, therefore Cartesian equation of required line is, say here, x minus y minus z minus. Now numerator space for x1 y1 z1. What is x1 y1 z1? Minus 2. So put here minus 2. So minus minus plus 2. y1 is 4. z1 is minus 5. So minus minus plus 5. Upon these numbers 3, 5, 6 or 3, 5, 6. 3, 5, 6. So to write Cartesian equation, we need only these three numbers and these three numbers. Vectors are required for vector equation. Here vector equation is not asked, but we can put vector equation. Vector equation is, vector R is vector A plus minus 4j minus 5k plus lambda times 3i plus 5j plus 6k, lambda belongs to R. So this is vector equation. Now next topic is angle between two lines. Say when finding angle between two lines, if lines are in the plane, then intersection is must. If two lines are in the plane and if they are intersecting, then at point of intersection, measure of acute angle is said to be angle between two lines. But now we are talking about angle between two lines in the space, both lines in the space. So when two lines are in the space, then it may not necessary that they always intersect. They may not also intersect, even though we can find angle between them. If lines do not touch each other, even though angle is created, and that can be found. So see, result is, if E1, B1, C1 and E2, B2, C2, these are direction ratios of two lines in the space, E1, B1, C1, that is direction ratios of first line, A2, B2, C2, that is direction ratio of second line in the space. Then angle between them can be found, by formula cos theta is modulus of A1 A2 plus B1 B2 plus C1 C2 upon square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. Now see, same result in different form. That means if equations are in vector form, if equations of lines are given in vector form, then how to find angle between two lines, that we are discussing. If equations of lines are vector are equal to, see here, vector A1 plus lambda times B1, lambda belongs to R. Second line is vector R equal to A2 plus lambda times B2, lambda belongs to R. If vector equations of two lines are, see there are two lines, that's why we differ this position vector of given point. A1, vector A1 is position vector of a point on first line, A2, vector A2 is position vector of a point on second line. This is vector parallel to first line, this is vector parallel to second line. They are creating angle. So if equations are given in vector form, then angle between lines can be found by cos theta equal to modulus of dot product of B1 and B2. Say this was nothing but a dot product of B1 and B2. These numbers are numbers in denominator of equation upon magnitude of B1 into magnitude of B2. This implies theta equal to cos inverse magnitude of B1 dot B2. Sorry, this is modulus of dot product of vector B1 and vector B2 upon magnitude of B1 into magnitude of B2. See, in numerator there is a modulus of dot product. Dot product is a scalar. Scalar means a real number over which we speak modulus, and this is magnitude. Magnitude word is for vector. So theta is obtained by cos inverse, and because it is obtained by cos inverse, here value of theta will be always belonging to 0 to pi. 0 to pi, that is angle between lines. So here, if dot product of B1 and B2 is 0, if dot product of B1 and B2 is 0, that means if you keep here 0, cos inverse 0 is pi by 2. Then angle between these lines is 90 degree. And say, because here it is a modulus, when cos inverse works on a positive number, it generates a value between 0 and pi by 2. Angle between line is always belonging to 0 to pi by 2. It must be acute angle. So pi by 2, that means 90 degree. When lines are perpendicular, angle between them is 90 degree. And if B1 is parallel to B2, that means B1 cross B2 is 0. B1 cross B2 is 0. That means these vectors are collinear. So angle between them, angle between B1, angle between lines theta will be equal to 0. So these are results to find angle between lines. Find angle between these two lines. Both equations are in vector form. Now see here, this is a vector parallel to this line. So let me say this vector is B1. B1 is 3i plus 2j plus 6k, and vector B2, that is vector parallel to second line, that is I plus 2j plus 2 times k. Now formula is theta equal to cos inverse modulus of B1 dot B2 upon magnitude of B1 into magnitude of B2. So to substitute values, we find dot product B1 dot B2. Dot product is 3 into 1 is 3 plus 2 into 2 is 4 plus 6 into 2 is 12, that is 19. So this value is 19. Magnitude of B1. Magnitude of B1 is square root of 9 plus 4 plus 36. So this is a square root of 49. Square root of 49 is 7. Magnitude of vector B2. Magnitude of second vector is square root of 1 plus 4 plus 4 square root of 9, that is 3. So angle between both lines is, putting in this formula, cos inverse modulus. See, dot product is 19. This can be also negative, but because of modulus, removing modulus, it will be converted into positive. Upon magnitude B1 is 7, magnitude B2 is 3. That is cos inverse 19 by 21. This is required angle. Now see here, similar method. Find angle between lines. These equations are given. We can use this form to find angle, or we can also use direction ratios form, that is A1 B1 C1, A2 B2 C2. See, these are A1 B1 C1, these are A2 B2 C2. Before taking A2 B2 C2 direction ratios, always check here coefficients must be 1. Or from this Cartesian equation directly we can also take vector B1. B1 is 2 to 1, that is 2i plus 2j plus 1k. Vector B2. Vector B2 is, before taking a vector, check here coefficients 1x, 1y, 1z. If 1x, 1y, 1z are given, then and only then you can take these as direction ratio. So applying this direction ratio with ijk, this is a vector parallel to that line. Now by similar method you can finish this question. Now say here, show that line through the points. Let me say this point A and B. Point A is 4, 7, 8 and B is 2, 3, 4. Line passing through these 2 points. Coordinates of points are given. So direction ratios of line EB, direction ratios of line passing through these 2 points EB are 2 minus 4 minus 2 comma 3 minus 7 minus 4, 4 minus 8 minus 4, x2 minus x1, y2 minus y1, z2 minus z1. These are direction ratios. So this can be taken as A1, this as B1, this as C1. And now C, this point is C and this point is D, 1 to 5. Second line passing from C and D. So direction ratios of line CD. Direction ratios of line CD are x2 minus x1, so it is 2, comma y2 minus y1, that is 4, z2 minus z1, that is 4. These are direction ratios. Now this is E2, this is B2, this is C2. Now if angle between line EB and line CD is theta, then cos theta is modulus of A1 A2 plus B1 B2 plus C1 C2 upon square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. This is nothing but different form of this formula. B1 dot B2. This is nothing but a dot product of vectors showing direction of this line. See, these are direction ratios. Means these are scalar components of vector which is parallel to this line AB. So vector B1 is minus 2i minus 4j minus 4k. Similarly, vector B2 2i plus 4j plus 4k. So you can also write vector B1, vector B2. You can also apply this procedure. Otherwise, use this formula using direction ratios. So here this is equal to, now say here A1 into A2, minus 2 into minus 2, that is minus 4, plus B1 into B2, minus 16, plus C1 into C2, minus 16 upon square root of A1 square plus B1 square plus C1 square, A1 square, that is 4 plus 16 plus 16 into square root of A2 square plus B2 square plus C2 square, that is 4 plus 16 plus 16. So it is equal to, this will be 36 upon, this will be also 36, root 36 into root 36, that is 36. So it is 1. cos theta is 1, so theta is 0. Therefore theta is 0 degree. That means lines are parallel. Therefore line EB is parallel to line CD. See, this is one method. Other method to show lines are parallel, here I am showing alternate method. So here alternate method. So here A1 by A2 equal to B1 by B2 equal to C1 by C2. Let me check. A1 by A2, B1 by B2, C1 by C2. If A1 by A2 equal to B1 by B2 equal to C1 by C2, then lines are parallel. If direction ratios are in proportion, A1 by A2 plus B1 equal to B1 by B2 equal to C1 by C2, then lines are parallel. Now check here. See, here minus 2 by 2. B1 by B2 minus 4 by 4. C1 by C2 minus 4 by 4. This is true. It is true. Therefore, A1 by A2 equal to B1 by B2 equal to C1 by C2. So lines are parallel. One more method. If we show cross product of vector B1 and vector B2, cross product of vector by these three numbers and its cross product with second vector which is obtained by these three numbers, B1 cross B2, if cross product is 0 vector, then also lines are parallel. So this is a short way to show lines are parallel. Now find the value of P so that these lines are at right angle. Say here 1 minus x by 3 equal to 7y minus 14 by 2 times P is equal to z minus 3 by 2. Now before taking direction ratios from denominator, always check numerator. Coefficient of x must be plus 1. So change here sign. X minus 1. So do change in denominator. Here 7 is not required. So divide by 7. So y minus 2. Because numerator is divided by 7, divide denominator by 7. Equal to z minus 3 by 2. So here we can see that vector B1, it is minus 3i plus 2p by 7 times j plus 2k. This can be taken as vector B1, a vector parallel to this line. Or we can say these three numbers are direction ratios. You can take A1, B1, C1. Now second line is 7 minus 7x upon 3p equal to y minus 5 by 1 equal to 6 minus z by 5. Again we want here 1x not minus 7x. So what we do, we divide by minus 7, so it will be x minus 1 dividing by minus 7, so minus 1, here divide by minus 7, so 1x. So denominator also we divide by minus 7. It is equal to y minus 5 by 1. Here coefficient of y is 1, so it's okay. Here we have to change the sign, z minus 6 by minus 5. So coefficients of x, y, z are 1, 1, 1. After setting that Cartesian form, standard Cartesian form, get vector b2. So vector b2 is, therefore vector b2 is minus 3p by 7 times I plus 1 times j plus minus 5 times k. Now here given that lines are perpendicular, as lines are perpendicular, dot product of b1 and b2 is 0. This is b1, this is b2. Dot product is 0, that means minus 3 into minus 3p by 7 plus 2p by 7 into 1 plus 2 into minus 5 is 0. That means this is 9p by 7 plus 2p by 7 minus 10 is 0. Therefore 9p plus 2p minus 70 is 0. So 11p is 70. So p is equal to 70 by 11.